The sun is hot, like really hot. And since it's the reason that we have warmth and light here on Earth, it's a pretty important thing to understand. Like, why is it so dang hot? And will it ever get cold? You know, if the sun were to get cold, that would suck. We'd all freeze to death, so we should probably do something about it, but how? To answer these questions, we need to go to the center of the sun. The sun is mostly made of hydrogen and helium, and those elements are only held together by nuclear fusion. At the center of the sun, the temperature is around 15 million degrees Celsius. That's hot enough to strip away all the electrons from those atoms, leaving behind a sea of protons and neutrons. Now, those protons and neutrons are known to be able to fuse together under extreme heat and pressure to make new elements like helium. And that process releases a tremendous amount of energy in the form of light and heat. So that's where the sun's energy comes from. It's literally just a giant nuclear fusion reactor. But that raises another question, which is, why does nuclear fusion only occur at the center of the sun and not in things like our nuclear fusion reactors here on Earth? Well, it turns out that in order for nuclear fusion to occur, you need both extremely high temperatures and also very high pressure. Here on Earth, we can achieve temperatures that are hot enough for nuclear fusion, but we just can't get the pressure high enough. At the center of the sun, however, both the temperature and pressure are high enough to get that fusion reaction going. But wait a minute, how does the sun maintain such high temperatures and pressures? Well, it turns out that gravity actually plays a big role here. All of the mass of the sun's enormous body creates a strong gravitational force that pulls everything towards its center. And as stuff gets pulled towards the center, it heats up because of something called conservation of entropy. Basically, when the particles get closer together, they move faster. And since all of the sun's matter is being pulled towards its center, all of the particles at the center are moving really fast, which heats it up. In fact, the sun's core reaches 15 million degrees Celsius, which is hot enough for nuclear fusion to occur. So basically, the sun is just a giant ball of hot plasma that's held together by its own gravity, and it's the gravity that also makes the sun hot. But there's another effect that gravity has on the sun that helps it maintain its temperature. You see, the hotter something is, the more energy it has. And the more energy it has, the more entropy it has. And the more entropy something has, the less likely it is to collapse. So basically, the higher the sun's temperature, the less likely it is to collapse under its own gravity. This is known as hydrostatic equilibrium. And it's what keeps the sun from collapsing in on itself. But will the sun ever get cold? Well, the answer depends on what you define as cold. The sun will eventually run out of hydrogen fuel, and once that happens, it will start to collapse in on itself. But even when the sun collapses in on itself, it won't get cold because of that entropy thing we talked about earlier. In fact, it will become even hotter. In its dying days, the sun will become a red giant, and then a white dwarf. And while both of those are significantly cooler than our current sun, they are still extremely hot. The white dwarf remnant of our sun will be about the size of Earth, but will still be around 8,000 degrees Celsius. So no, the sun won't get cold anytime soon, but if you don't like being hot, you should probably move to Antarctica.